Rational indices. There are two more index laws which we're going to consider here. We need a slightly different approach to derive them. Consider the meaning of a square root. For example, we know that root 9 is equal to 3. And that's because 3 multiplied by 3 gives us 9. In this case, we looked at a number which had a rational square root because we considered 9, which we know is a square number. But now consider a surd. The square root of 2 multiplied by the square root of 2 gives us 2, in exactly the same way that the square root of 9, which is 3, multiplied by the square root of 9 gave us 9. This is the very definition of what a square root is. Now consider the index laws. 2 to the half multiplied by 2 to the half would be 2 to the power 1, and remember we don't normally write the 1. So 2 to the half times 2 to the half is 2. Comparing, root 2 times root 2 is 2, and 2 to the power a half times 2 to the power a half, remember we add the indices here, is equal to 2, shows us that 2 to the power a half must be equal to the square root of 2. Now consider that the cube root of 2 multiplied by the cube root of 2 multiplied by the cube root of 2 would also be 2, which would be the definition of a cube root. 2 to the third times 2 to the third times 2 to the third would be 2 because we add the indices, and a third plus a third plus a third is 1, from which it follows that 2 to the power 1/3 is the cube root of 2. Clearly, we can continue this pattern looking at fourth roots and fifth roots and so on, and it leads us to the general result that a to the power 1 over n would be the nth root of a. Now recall the index law, a to the power n to the power m, this is a power of a power, is equal to a to the n times m. So if we had a to the 1 over n to the m, if we multiply m and 1 over n, we get m over n. And if we have a to the 1 over n to the m, we can also write the a to the 1 over n from here as the nth root of a. But also, if we have a to the 1 over n to the m, because we're just multiplying these indices, we can interchange them and have the m inside the bracket and the 1 over n outside. And that would give us the nth root of a to the m by following the index law. And that leads us to our final index law, which is that a to the m over n is equal to the nth root of a to the power m, which is also equal to the nth root of a to the m. Now, in usage, quite often this one is the best one to use because it keeps the numbers smaller, and very often you do index work without a calculator. But we have two more index laws, this one here and this one here. And really it's only one because this one is just this one with m equal to 1.